So good morning, ladies and gentlemen. Yesterday, you guys all completed your Newton's first law quiz. Up to that point, we talked about Newton's first law, also known as law of inertia. We've talked about weight. We talked about finding the net force, and we talked about drawing free body diagrams. Well, today we are going to discuss Newton's second law. So again, ladies and gentlemen, I would like you guys to copy these notes down into your note packet, because we want to keep that nice and neat so we have that all together to study for when we have a test or a quiz. So Newton's second law. Well, what is Newton's second law? Newton's second law is probably one of the most famous laws that Newton made, and the most popular one. So Newton's second law says that acceleration is produced by a net force on an object is directly proportional to the magnitude and is in the same direction as the net force, but is inversely proportional to the mass of the object. So that is a long definition for Newton's second law. And really it's what does all that mean? Well, we can sum that all up into one equation. One equation, ladies and gentlemen. A equals F net over M. Well, this is on page 6 of your reference table. So everybody right now should go and look at the reference table, page 6, and find this equation. Well, this equation right here can also be written as, and seen a lot of the time, as this. F net equals M times A. Either one of these are okay to use. Either one of these are perfect to use. This is on your reference table, but if you want to remember it as this, that's okay as well. Well, let's figure out what these variables are. Well, we have that A is our acceleration. And what are the units for acceleration, ladies and gentlemen? Meters per second squared. You have F net, which is the net force. Remember, don't forget, we know how to solve for the net force. And what is force measured in? That's measured in newtons. And then last but not least, we have M. M is your mass. And we know that in this class, we're always going to measure mass in kilograms. Kilograms. So perfect. So now we know what the long version of definitions. We know what our equation is we're going to use. And we know our variables. Well, it's important to note that force and acceleration are both vectors, right? We should remember this. It is important, guys, in this class to know which are scalars and which are vectors. So because they're both vectors, they're going to need magnitude and direction. And because they need both magnitude and direction, we can say that the direction of acceleration which we know that acceleration is just a change in velocity, right? That's going to be a change in direction. Is equal to the direction of the force. So whatever direction the acceleration is going in, that's the direction of the force. Very important to note, ladies and gentlemen. Very, very important. Well, now let's look at the relationship between acceleration and mass and acceleration and net force. So in that long definition I wrote, we said that acceleration is directly proportional to the net force. Well, what does that mean? Well, first let's look at a graph. So if I was to graph out F net and acceleration, what is that graph going to look like? That graph's going to come out to look like something like this. And what does that tell us? Well, let's write out our equation. A equals F net over M. It says these are directly proportional. So what that means is what happens to one happens to the other. So if F net goes up, we increase the F net, the acceleration increases. If F net goes down, then acceleration goes down. It is directly proportional. Whatever happens to the F net happens to the acceleration. That's why if you look on this graph, as F net gets bigger, acceleration gets bigger. And as F net gets smaller, acceleration gets smaller. It is directly proportional. Ladies and gentlemen, it's very important to be able to make that relationship known. Well, I also said one more relationship. There's one more relationship, and I said that acceleration is inversely proportional to mass. Inversely proportional to mass. Well, what does that look like on a graph? So if I have my graph, I have mass or acceleration on the y. Well, that's going to look like this. It's going to be an exponential. And now what is that saying? Let me write out my equation again. A equals F net over M. Well, this right here, this relationship is going to be an inverse relationship. And what does inverse mean? Well, inverse just means if I increase one, the other one decreases. If I decrease one, the other one increases. So let's look at this. As mass increases, acceleration is going to decrease. Acceleration is going to decrease. As mass decreases, acceleration is going to increase. Acceleration is going to increase. Inverse relationship. What happens to one, the opposite happens to the other. And if you look on our chart here, our graph, as mass is increasing, acceleration is decreasing. And then as mass is decreasing, acceleration is increasing. Inverse relationship. So, what does all this come out to say? All this basically comes out to say is that when you have a constant net force right? So I'm applying the same net force on each object. Mass increases, acceleration decreases. You have that inverse relationship, right? If I apply 10 newtons of force to one object, and then I apply 10 newton force to a second object that is heavier, right? Our mass is increasing. We're not going to be able to accelerate as fast. The object's not going to be able to accelerate as fast. And then same as if mass decreases, that object's going to accelerate faster if I apply that same force. And then, as we talked about previously, if I have a constant mass, right, so my mass is staying the same, and I increase the net force I'm applying on the object, well, guess what? That acceleration is going to increase. My mass is staying the same, but I'm increasing the net force applying. And if my net force decreases, your acceleration decreases. So this is two relationships. They're very important to know with Newton's second law. Now let's talk about getting into actual problem solving. And that'll be on our next video.